Welcome protein coders, let's build some coding muscles. Today we're going to see shortest path in undirected graph with unit weights. Unit weight means the weight of the edge between any two nodes will be unit. Okay, and the graph will be undirected. So we will be given a graph and we have to find the distance of each and every node from our starting node. Okay, let's say 0. So let's see how we're going to do it using DFS. So 0 will be at distance 0. Then we will move to 2, it will be at distance 1, and 4 will be at distance 2, and similarly we will fill our distance vector. Okay, now look here, it is wrong because the node number 1 will be at a distance 1 from the node 0, right? So there is something missing. For that, let's do the DFS traversal from other path. And this time you will see few nodes are again correct, but few are not. And we have to take minimum of the distances of each node in each DFS call. Okay. Now this is our correct answer. The node 0 is at distance 0, 1 and 2 at distance 1, 3 and 4 at 2, and 5 and 6 at 3. So what we got an observation, if we are going to do using DFS, it will take too long, right? We have to visit the same node multiple times and take the minimum distance of each node, right, from the 0. So it is not preferable. Let's see how we're going to do it using BFS. So 0 will be at distance 0, 1 and 2 will be at distance 1, 3 and 4 will be at distance 2, and 6 and 5 will be at distance 3. And in first pass only we got the correct answer. We don't need to visit the nodes again and again. Right? We don't need to change the distance vector again and again. So that's why BFS is preferred over DFS. Such cases. Okay, no need to update the distance vector again and again. And DFS, let me write it down, visiting nodes multiple times, and BFS just visiting neighboring nodes once. So the time complexity of BFS is better. Now let's see in the code how we're gonna write it. Let's get the size of the adjacency list or number of vectors. Then we will have a distance vector initialized with -1. Then mark the distance of source 0, push it into the queue, and start our BFS traversal. In BFS traversal, we will get the node, we will pop it out and look for the neighboring nodes. Complete to copy of our BFS traversal. And if we found that the neighboring node is not visited or distance it is -1, we will mark it as distance of node +1 and push it into the queue. That's it. Finish. At the end, we will return the distance vector. That's all. Let's see what we studied today. In DFS, we see if you want to find the distance vector using DFS, we have to do multiple DFS calls and we have to update distance vector again and again, which increases the time complexity as it is not preferable. Then in BFS, we saw that our life becomes very much easy, right? We just filled the distance vector in single pass, and if you look carefully, what we are doing here is we are moving level wise, right? And at every level is what the distance of the node from the starting node, right? 0 will be at level 0, then 1 and 2 will be at level 1, 3 and 4 will be at level 2, and 6 and 5 will be at level 3. Then we wrote similar logic into our code. It's a simple BFS traversal, and this, if we find any unvisited neighboring node, we will mark its distance in the distance vector is equals to distance of node +1. Okay, then we return distance vector. So that's all from my side, guys. If you have any questions, please mention them in comment box. Problem and solution links will be in the description box. If you don't understand, don't like, don't subscribe, but if you do, please show some support. Keep smiling, keep practicing. Thank you.